This video is on multiplying and dividing rational expressions. To multiply rational expressions, we're going to factor the numerators and denominators and put everything in one big fraction, keeping everything on top, still on top, and everything on the bottom remains on the bottom. But then we're going to have some common factors that will reduce. This basically follows the regular rules of multiplying fractions. So to begin with, let's take our fractions, and since we're going to make one big fraction out of the answer, we'll make a large fraction bar, and anything that's on top will stay on top. But if we can factor it, we will. So x plus 7 can't be factored. I will suggest that you put it in parentheses. This reminds us that everything is being multiplied. If you look at x squared minus 3x minus 40, I hope you see that it can be factored. And while you can use methods like the pants method or the box method, since there's a leading coefficient of 1, we can use the shortcut, and I hope that you do. It will save you a lot of time. So we're looking for two numbers that multiply to negative 40 and add to negative 3. And those numbers would be negative 8 and positive 5. So x minus 8, x plus 5 is the factored form of this polynomial. So now we'll go to the bottoms and we'll factor anything we can factor here. Well, 7x plus 35. The first thing you always look for when factoring is a GCF, and there is one. 7 is in common. Now it's a common mistake not to write that 7 down. Be careful that when you do GCF, you always write that GCF in front of parentheses. You don't just get rid of it. It doesn't disappear. To fill in the parentheses, remember factoring is just the opposite of multiplying. So if you were doing the arrows here, what would you multiply 7 by to get 7x? And what would you multiply 7 by to get that plus 35? And there's an x minus 8 in this second denominator, and since there's nothing we can do to it, I'm just going to write it there, again, in parentheses. Everything should go in parentheses. Once you factor everything and put it all in one big fraction, the idea is to cancel any common factors, because anything over itself is 1. So the x minus 8's cancel and the x plus 5's cancel. I want you to be careful when you have something like this left. Remember that any terms attached by a plus or minus can't be separated. So you cannot cancel those 7's because the one on top is sort of connected to that x. Anytime it's connected by a plus or a minus, it has to stay together. You can't break it apart. This is our final answer. So let's look at dividing. When we divide rational expressions, looks very similar. There's one extra step. The rule for dividing fractions is keep, change, flip. What does that mean? Well, it means that we're going to keep the first fraction. We're going to change division to multiplication. And we're going to flip the second fraction. So numerator and denominator trade places. Now, all we have to do is follow the directions for multiplying. And we know that when we multiply, we go straight across. Be careful. Look at these. Don't try and do the box and multiply this trinomial times this binomial. This is going to be much easier to factor and be able to cross things out by canceling anything over itself. So to factor the first part here, let's make our big fraction bar. The first part factors using the shortcut. You want two numbers that multiply to positive 16 but add up to 10. And those two numbers are 8 and 2. We always put whatever variable is being used right there. And they're both positive because everything's positive up there. I also have an x plus 4 in that other numerator, so I'm going to put that also on top. Remember, everything that's on top in the numerator stays on top, and everything that's on the bottom in the denominator stays on the bottom. So now I'm going to factor the x squared plus 6x plus 8, and when you do that, you get x plus 4, x plus 2, and there is also a 1. You can write it or not, but of course multiplying by 1 won't change anything. Again, look for a match, top to bottom. Be careful. If there's more than one x plus 2, let's say in the denominator, you can only cancel one item for one item, one expression that matches. You can't cancel both of them. We also have some x plus 4s that match numerator to denominator, and all we're left with is an x plus 8 over 1. Well, we don't need the over 1, so your solution is just x plus 8.